Good morning. Lesson 6-6, inequalities. So first we should do some definitions, and they're handily written for you down at the bottom, way down here. This little symbol is the less than symbol. You could also say fewer than. We read them left to right, so you might read 4 is less than 100. Okay. This symbol is the greater than symbol. And then these you might not have seen before. This is the less than or equal to symbol, or is at most. So 4 could be less than or equal to 4 because the equal to. Here's how that symbol was made. Here's your equal sign, but maybe it's less than or equal to. That's kind of where it came from. And then the opposite is also true, is greater than or equal to. Or you could say is at least. So like if a number is at least 3, that means at its smallest it could be 3. But could the number be 5? Yeah, it just can't be less than 3. Okay? So an inequality is something that's probably not equal. So instead of where we would normally have an equal sign and we would solve 1 plus x is 6, right? Now when we solve, we have that symbol in between. So x has to be greater than or equal to 5. And if you think about it, if 1 plus 5 is 6 greater than or equal to 6? Yeah. Could x be 4? No, because, well, 4 wouldn't fit this definition, but also it wouldn't make sense. 1 plus 4 is 5, and 5 is not greater than or equal to 6. So they say here, the solutions could be 5 or anything bigger than 5. That's what the dot dots mean. So inequalities can get a little complicated, but I think to start with, we'll try to not keep them complicated. Okay? Let's go down to this one. A person must be at least 18 years old to vote. Write an inequality to represent the possible ages of the voters. So at least 18. Well, let's go back here and see what at least was. Where did we find at least on our list? Oh, here. So someone, this symbol, 18, because they have to be at least 18 to vote. The person is at least 18, means they could be older than 18 or they could be 18, but they can't be less than 18. Okay. In some states, you must be at least 16 years old to have a driver's license. That's like in the state of Oregon. Write an inequality to represent the age at which you can have a driver's license. So again, at least the person has to be older or can be 16. Okay, let's do this check, see how we did. A certain hotel only permits dogs that weigh less than 50 pounds to stay with hotel guests. Write an inequality that can be used to represent the weight W of dogs that are permitted to stay at the hospital. So we have W and 50 pounds. Now the dogs weigh less than 50. Can the dog weigh 50 pounds? No, it doesn't say less than or equal to. So the dog has to be less than 50 pounds. So don't worry if some of this takes some slow down and some thinking. Now we sometimes have to work on number lines because we're going to graph these. Oh, listen, graphing them is really kind of interesting. So if we're going to graph the inequality, x is greater than 3, can x be 3? No, x cannot be 3, so we have an open circle. Open circle does not include the number where it is graphed. And then if it can be greater than, then it includes all of the things to the right. Down here you'll see they sort of made a bolder line and put a bigger arrow. I kind of like to make it obvious myself. All right, so if we were going to graph the inequality x is less than -1, could x be -1? No. So it's an open circle, and then less than means to the left. Okay, that's how you graph them. Graphing them turns out to be advantageous later in math. So learning this now is a pretty good idea. All right, x is less than or equal to 2. Could x be 2? Yes, because of this part. So we have a closed circle. And then if it's less than, it can be 2 or anything to the left of 2. If x is greater than or equal to -7, could x be -7? Yes, closed circle. And if it's greater, then we need all this stuff to the right. Okay? Let's try it down here. X is less than -5.75. So we got to find -5.75. Is it here? No. See how there's a 4? So when we're in the negatives, to get further away from 0, you have to be to the left. So it's actually going to be right here. Now, can x be 5.75? Does this say equal to? No. So we have to have an open circle. And then less than means to the left. X is greater than 1 2/5. Can x be 1 2/5? No. So we're going to have open circle. X greater than 1 2/5. 1 1/5, 2/5. And greater than means to the right. Okay. Graph the inequality. X is greater than or equal to 2/5. Could x be 2/5? Yes, closed circle. Well, here's 2/5. Is it this one? No, there's the negative, right? No negative up here. So we got to find this one, closed circle, and then greater than, so to the right. Okay. X less than or equal to -0.75? Yes, it could be -0.75, so closed circle, and less than, so to the left. Okay. Let's find some solutions to inequalities. Using the substitution method, are these solutions to this? 2 plus x is greater than 9. So we substitute the value of the variable. They give you the value, you put it in for the variable, and then you solve. 2 plus 5 is 7. Is 7 greater than 9? No. So 5 is not a solution. 6. 2 plus 6 is 8. Is 8 greater than 9? No. So 6 is not a solution. 7. 2 plus 7 is 9. Is 9 greater than 9? No. How about 8 for x? 2 plus 8 is 10. Is 10 greater than 9? Yes. How about 9? 2 plus 9 is 11. Is 11 greater than 9? Yes. So in this list, those two would be solutions. Okay, similarly, if we have a plus 4 is less than or equal to 11 and they give us some variable values of a, we substitute them in. Where there's an a, we put a 6. 6 plus 4 is 10. Is 10 less than or equal to 11? Sure is. 7. 7 plus 4 is 11. Is 11 less than or equal to 11? Yeah, 11 equals 11. And 8. 8 plus 4 is 12. Is 12 less than or equal to 11? No. Right, so 6 and 7 would be solutions. Again, you could use the substitution method, or let's go over here, or we could just solve. C plus 28 is greater than 72. So what's happening to the variable? We're adding 28. So let's do the opposite of that. 72 minus 28. 72 minus 28 is 44. 44. So C is greater than 44. So in this list, is 44 greater than 44? No. Is 45 greater than 44? Yes. Is 46 greater than 44? Yes. So in this list, 45 and 46 would be solutions. Okay, and that's how you do it by solving. All right, let's do this last one. At the end of his vacation, Mr. Ote has $55 left to spend at a souvenir shop. He would like to buy some picture frames that cost $12.75 each to display some of his vacation photos. The inequality, 12.75F, is less than 55, represents the number of frames he can choose to buy, because the number of frames would be F and their price is $12.75 each. He has to spend less than $55. Technically, I think he could spend less than or equal to $55, but we'll go with what they say. What is the greatest number of frames he can buy? So we could solve for that. You could use guess, check, and revise. But now that we've been doing algebra for a week and a half, perhaps we could just do some inverse operations. What's happening to the variable? It's being multiplied by 12.75. So what's the inverse of that? Divide by 12.75. 55 divided 12.75 is 4.3 something, ... So can he buy 5 frames? No, because 5 is bigger than this number, right? So if we put a 5 in for the F, 5 was bigger than this. The number of frames must be less than 4.3, so he could buy 4 frames. You're not going to buy 0.3 of a frame, probably. Okay? Good luck.